and also the fact that they generate way more CO2 than what they need actually within their own facility. So they only need about 10 to 20% of the CO2 that they actually generate. So what do they do with it? And also the cost to capture CO2, compress it, and be able to utilize it is expensive. So how do we make that payoff work if we're only if we're only capturing and using 50% or 15 to 20% of our production, just because that's our own usage? Now, if we were to do that with current technology, the ROI on that was about 10 to 12 years. It was not an attractive project, not something I would recommend. Certainly environmentally beneficial, but it doesn't have the economics for the business. Yes, it's good for the community because we're capturing greenhouse gases, but it just financially didn't make sense. That's where cannabis comes in, because again, cannabis uses CO2 within the grow environments to be able to absorb the lights and optimize the plant growth in that really short condensed time frame. Because when outside 6 to 9 month grow cycle, inside 2 to 4 months, on the, I would say more like 2 months, in order for the plant to grow to the same size it would in 9 months, we have to provide all the elements for light. That's why we're force feeding it nutrients. That's why we're keeping it under lights, in certain stages, 24 hours a day in the veg stage, 18 to 24 hours a day, and 12 hours a day, certainly during the flowering stage, sometimes as low as 8. Facilities play with those numbers and do what works best for them. But this is where these two business sectors can come together. So at the brewery, we're capturing as much CO2 emissions as possible, more than what they would need. We compress it with some unique equipment provided by Earthly Labs technology. That's that center picture. It essentially looks like a refrigerator. We're collecting the CO2 that's coming off of the fermentation tanks. It goes into that device. It's filtered. We make sure that it's pure, things like that. It gets condensed and then put into that tank that's sitting next to the refrigerator looking thing. That is a 500-pound CO2 tank that is then taken over to the grow in the last picture and released within the flowering room to provide that supplemental CO2 so those plants are happy and can grow to their optimal performance. So this project is basically capturing a waste stream, turning it into a commodity, and then we're also creating a CO2 sink for it. That the plants take in CO2, they use the carbon, they release the oxygen, the CO2 is eliminated. So really beneficial for both businesses. It cut the price of CO2 for the marijuana cultivation by about 20%. Return on investment timeframe for this project was 18 months for both the brewery and the marijuana cultivation. After that, it provided on the low end, where we're just providing 1 of 6 rooms at the marijuana cultivation during the trial period. They're expanding up to all 6 rooms here over the last year. I think they're up to like 4 now. We're adding on, doing a full facility conversion to the CO2. But even on the low end, when they were only providing 1 of 6 rooms, it was about a $6,000 a month new revenue stream for the brewery. That's really beneficial, especially this last year. This pilot took off. We started testing it in February of 2020. March 2020 is when COVID hit, and the brewery had to shut down their tap rooms. Marijuana cultivation was really stressed because during the pandemic, sales of marijuana skyrocketed. So the brewery's closing their tap rooms, but at the same time, the marijuana facility is having to produce more. But the breweries were selling more beer in retail locations. However, they lost some revenue from having to close their tap rooms. Also, at the same time, oil and gas prices tanked. And usually typical CO2 suppliers, it's a byproduct of power generation. We capture the CO2 off of generating power, and then that's sold to the brewery, to the marijuana cultivation. That's typically the supply of CO2. Well, when oil and gas prices tanked, CO2 supply went down. And so costs skyrocketed during the pandemic to get CO2, and there was a scarcity. These two businesses had no problem because they became their own CO2 supplier. They generate it, they sell it, they're locked into the same price. They're not tied to this global supply chain and impacts. The brewery was able to, compensate with this project for some lost revenue of having to close their tap rooms. It really worked out great. It's a very repeatable project. It did not receive any supplemental funding whatsoever from government. Myself, I was only, technical project manager, brought the two companies together, provided the idea. They all purchased the equipment and get all the agreements in place by themselves, and still be able to maintain an 18-month return on investment timeframe. That's unheard of. It was such a successful project. The governor of Colorado, Governor Jared Polis, came out and supported the project of both the brewery and the marijuana cultivation. I don't know of many other governors who are going to marijuana cultivations and actively praising them for sustainable operations. This is so cool to me. I'm a native to Colorado. I went to CU Boulder for my mechanical engineering degree. I did a little bit at a local community college and at CMC, Colorado Mountain College in Steamboat. Born and bred in Colorado. Never did I expect to see our governor standing in front of marijuana plants and then going to a brewery and having a beer because of an engineering project that I did. That was just mind blowing to me. So very cool project. Really made it came together. And the lesson here is leveraging simple science and reusing a waste stream. Look at all the inputs to your process. Look at all the outputs to your process. Find value in that. Reduce your inputs, maximize your outputs. That's really what we're going for with sustainability. So I'm gonna try to wrap up real quick with just giving you guys some resources and then leave some time for questions. This is that Colorado website that I mentioned that has really great guidance on air, waste. We have an environmental leadership program that any cultivators in Colorado can qualify for and get awards for their sustainable efforts. We have other sustainability resources listed on there. I can't recommend enough for anyone that has an interest in cannabis and the environment to take the time and read the National Cannabis Industry Association's environmental report. It came out last October. It's still very, very valid information. It condenses a very, very complex topics into 60 pages of information. Sometimes people hear 60 pages and they're like, oh my gosh, I was on the team. I managed the team that wrote this. We initially started at a 350-page draft and condensed it down to just the most important concepts. So highly recommend you take the time to go through that if you have an interest. Really great information. Then also there's the Denver Cannabis Sustainability Work Group. That's our local level, Denver County. They have really great guidance documents that are created through a stakeholder group, and they're updated every year. So this year, the team, the new update will come out in October, and the new update is going to be, we're going to have a chapter specifically on climate change. We're going to have a new chapter on certifications, what all the certifications that are out there for sustainability in cannabis, what traditional certifications can be applied to cannabis, which ones are unique to cannabis. I'm excited about that new iteration of the guidance documents, but really good information there. I think in total, that one's around 200 pages worth of content, so a little bit more in depth than the NCIA documents. And then also, I mentioned a couple of times, certainly for energy and for water, it can also be a benefit for waste, but tracking your data, keeping track of your energy bills, understanding the changes in your energy footprint. When you make an upgrade, track how much of a difference it makes on your energy bill. How much money is that saving you? That's how you calculate your return on investment timeframe. Cannot stress metrics enough. There is a free tool out there that's relaunching this summer, hopefully in the next month or so, where cannabis businesses can anonymously put their data into the system and then get a report back that'll be visual representations, energy use over time, energy use per pound of marijuana produced, things like that. Really helpful visualization of your data. And then the really great part of it is it anonymizes data of all different cultivators, brings it into one picture so we can say, okay, here's a scatter plot of energy and marijuana production. Where do I fall? What are the top 25% producers? What are the bottom 25% producers? And what best management practices are associated with those metrics? So for somebody that's really, really energy efficient, what are they doing? Are they using LEDs? What type of HVAC system do they have? So we can really start to get data-driven best management practices out of this industry, because it's lacking a lot of data, primarily due to the federal legality of it. Nobody wants to share data at a state level under the risk of federal enforcement. I left some sustainability tips in there. I'm just gonna let those resonate. You guys can, we'll provide the slides after the presentation, so you guys can go through those, but really optimizing resource uses, data tracking, make sure you're talking to environmental permitting agencies early on in the process. You don't want to design a system and then figure out that you have to go back and add filters and upgrade your HVAC system and all of that because you were subject to an odor ordinance that you weren't aware of. Talk to your agencies early on, know what your compliance burden is, and comply from the start. It's much cheaper. LEDs are great. Carbon filtration is great. Where do I start with all this mess? I just threw a lot of information at you guys, 52 minutes worth of information. Start with data tracking. Let data drive your decisions. Organize a green team at your facility. Nobody is going to know how to optimize and improve your facility better than the people that work in it every single day. The staff on the ground who's working with the plants, who's running your systems, who's running your packaging equipment, who's extracting your plant material. Get your existing staff involved. It doesn't always take some outside person like me talking at you to tell you what to do. Organize a green team. Allow your staff an hour once a week to meet and discuss this. Make it a priority. Talk about behavioral changes. They are free. It does not cost you anything to have your green team sit around and put a sign that says turn the light off in the break room, or invest in a motion sensor that turns off low traffic areas like your hallways that nobody ever really goes down. Things like that. Those are really low cost, no cost options. Think about cleaning. Can I use a broom instead of a hose to, wipe up a spill? Can I save water? How can I make my cleaning products go further? Can I make my cleaning products, can I dilute them a little bit more and still get the same capacity out of them? Those are all behavioral changes that your staff will see the opportunity. You're already paying them to do these types of things. Make it a priority. Then start with those low cost, no cost projects first. Motion sensors are cheap. New nozzles for your irrigation system so that it has more efficient dripping, really cheap. You don't always have to jump into LED conversion right from the start, or installing a new CO2 system that can be $20,000. Work your way into it, bank those savings from those projects, and then you can continually invest. So it's a lot easier to go to your CEO and say, hey, I want $20,000 for this awesome new CO2 system that I'm going to get brew from the brewery down the street. If you've already had your staff start doing these behavior changes, you're tracking your data, so you can say, in March, we made it a priority to turn off lights and we saved ourselves $200 or whatever it is. You start banking and tracking those savings. Then when you go to the CEO and say, hey, I want a 20,000 investment, but my staff over the last 6 months has saved us $10,000 of that $20,000 investment, it's not such of a big sell and a big hurdle to overcome. So with that, question.
Thank you so much. That was super informative. I'm sitting here writing notes myself. A few things that I didn't know. We do cultivation facilities all the time, and RO is almost automatic. I didn't realize that it wasted so much money. We don't design the RO systems themselves. We just
Right.
provide the inputs and the outputs. But yeah, I'm definitely going to be pushing the UV and the other options that you showed.
And I
And
always
also,
recommend water testing up front. Why are you treating something if maybe you already have a really pure source of water? And like here in Colorado, we have, because most of our water is snow melt and runoff, it has the opportunity to pick up a lot of nutrients along the way. It already has magnesium in it, phosphorus, and potassium. It sometimes has a nutrient profile in it, and we don't take that completely out when we treat it to drinking water standards. So why zero out your water and then spend a lot of money on nutrients to add back into your system? Better to test your water, know what your baseline is, and then design treatment and nutrient load
yeah.
around that.
I mean, you look at whiskey manufacturers in the Southeast and they use springs, right? So there's a reason for that. I also didn't realize that everyone didn't use carbon filters. That's kind of automatic for us to make sure that those smells don't get out.